Hi, and welcome to another Hopper on Linux video. In this video, I'm demonstrating Hopper running on the Raspberry Pi. So Raspberry Pi, not Raspberry Pi Pico. And what you're looking at here is the remote desktop connection to my Raspberry Pi. It's a little bit sluggish because I'm using something from the Raspberry Pi Foundation called connect.raspberrypi.com, which is a built-in remote desktop that goes across the internet. Actually, it goes directly if they're on the same net sub network. Anyway, I'll go into full screen here, and there we are. And then I'll open my Chromium browser. It's taking a little while. Yeah, I can restore that page. So this is I did this new release for the Hopper runtime. And even though the Raspberry Pi has a 64-bit ARM chip, the default operating system that comes with it is a 32-bit operating system. So what we want is the runtime for Linux ARM, as opposed to later there'll be a Linux ARM 64, but we'll just download this for now. So we'll start that download. And we also want the regular full Hopper tree, so we'll download that. And let's open our file viewer and go to downloads. So how do I unzip that? Open the archiver, extract here. Let's try extract. No, let's extract to not much of a Linux guy. So let's just try extracting it to home. And yeah, not exactly what I wanted. Well, I can move that. I think I can move that to there. There we go. And then I can delete that. Can't really delete it in this. That's the first time I've used this file explorer thingy. It's got everyone's different. Yeah, move that to the trash. That'll do. Yes. So that should be my whole Hopper tree. And then I want to put the other thing in the bin folder. The download of the runtime. So that's this. So let's see what that folder is actually here. So bin, so that's the bin folder. And let's go back to, where was our downloads? And extract to that folder. Hopefully that'll work. And, oh, it put it in its own folder. It doesn't really matter. We can keep it in that subfolder. Anyway, the next step, I'm actually going to pause and undo some changes I made so I can make them again in the video. So let me pause the video. Okay, I made some changes, but I want to show you how to do them. So this is the default terminal on the Raspberry Pi, and it has this extra menu. And I don't want this extra menu here. I'll show you why. So if we go to cd hopper bin, and then what's it called, Linux, that folder. This is the folder where our binary is. If we look at the folder, and now chmod +x hopper. So you have to make it executable. So there's our hopper. And now if we run hopper, which magically appears on our 32-bit Raspberry Pi. Oh, this happens a bit too. So I've lost my connection. So I'm going to pause the video while I reconnect to the remote desktop. Okay, I've reconnected and I'll go back to full screen. And here we are again. So it's a bit hinky, but I mean, if you're working directly on if you're not making videos like me where you need to record them somewhere, we don't have to worry about this. So if I go edit readme.md, you can now see we've got two menus. We've got the consoles menu and our own menu. Anyway, so the changes I'm going to make, exit hopper. You can go into here, edit preferences. And I'm going to say hide the scroll bar. I've also changed my default window size to 120 by 30. It's bigger than the default 80 by 25. I'm going to hide the menu bar. And once you do this, you can't get back to the menu bar. That's why I had to go undo it. But I'll show you how you can undo that as well. And then what have we got under advanced? Disable F10, disable the Alt keys for tabs. And then we got shortcuts. I don't think I did anything to the shortcuts. Anyway, I make all those changes and that menu is now gone. So I only have one menu now when I open my my hopper. Now, if you ever want to revert it, under your home folder under .config lx terminal, this is called lx terminal, you can go and open this config. If you double click on it, it'll open it. No, just double click on that little there. It opens it in an editor, and you just go and change. There's a hide menu bar. Just change that to false and save it, and your menu bar will reappear. Anyway, enough about that. So we've got Hopper up and running. I'm gonna just minimize this so that it's not as distracting. And let's just run Hopper. Right. And if I go source samples, edit fiber uint. Notice how I do that all lowercase, even though if you look in the top right here, the actual file name is cased and the path is cased as well. The Hopper file system is case insensitive, no matter which platform it's running on. Nice smooth mouse, everything. So build, the shortcut would be F7. We'll just build that. Because it's not a remote microcontroller that is connecting to via the serial port, we don't have a debugger yet. So when you go build, launch debugger is disabled because it's not on a remote machine. Anyway, this doesn't end afterwards either. So I'm going to exit to the console and just run what I've just built, fiber uint, which is a uint-based Fibonacci sequence. And there it is. It ran Fibonacci 24, calculated Fibonacci, got it. So there was a Hopper program being built and run on a Raspberry Pi. So now let's try taking advantage of the fact that the Raspberry Pi is a single board computer with I/O pins. So, you know, it's got GPIO pins like a microcontroller. So unlike running it on Windows or on a regular Linux machine, we can actually use these pins. And I've wired up some LEDs. So the first LED there is on GPIO 4. So let's see how that's going to work here. So some changes compared to Raspberry Pi, compared to the microcontroller boards. There's a board called Pi. If I right click on that to go have a look, it says it's got a built-in LED. Even though the Pi doesn't have a built-in LED, I just made the first GPIO be the built-in LED. So if I build this, F7 to build, and then it's going to loop here, delay half a second, and toggle the LED, delay half a second, toggle the LED, right? So we should see that Rightland string come up twice for every toggle. Okay, I right-clicked on LED, so you can see what that property does now. It's actually a property of the GPIO unit, but because it's unique, I don't need to qualify it. I don't need to say GPIO.LED. And then it keeps the state of the LED, and it switches the pin mode of that to output, and then it'll switch it to the state. So LED equals true, LED equals false. We'll keep turning it on and off. Let's double click here to go back. F7 to build. And I've also said if IO is available, turn it off and exit so that I can hit the escape key. So IO is available, it's IO right line. And this is a generic way of doing either keyboard or serial IO. And this, inside here, we've got, this is the definition file for the first single board computer we're supporting, which is the Pi. And it uses a a unit called single board computer. And under single board computer, it's using I/O. And inside there, if it's a single board computer and it's not using serial, it'll use print and the keyboard to do the I/O. Whereas if it's a microcontroller, it'll use the serial port to do the I/O. Anyway, we've built it. So we can double click on that to go back. Have I lost my? Connection is disconnected again, so I'll just reconnect. I'll pause until it's reconnected. Okay, I'm reconnected again. Yeah, this remote desktop via HTTP is a little bit dodgy, but it's easy to make videos in. I mean, I'd rather work on my Pi directly with a keyboard and a screen, but this is good enough to work remotely. Okay, let's try that again. So Control F5 to run. So the number of seconds is the number of seconds that the power has been turned on this microcontroller, or since its last reboot. And you can see there's a little blue LED flashing. So that LED is on GPI Open 4, and it's being alternated by the simple, and let's press escape here. So that's I/O is available, so it comes back. Let's go do another demo. File exit. And the reason I'm using file exit is because annoyingly Alt F4 will exit this app. So I got to think about exit keys, because I managed to make that work properly on Ubuntu to not intercept Alt F4, but I haven't figured out how to do that here, and it's going to be a problem elsewhere. So maybe I just got to assume that I've got to change the exit key in all my apps to Alt X. I want it to be consistent across all platforms, so maybe I'm just going to have to change it. Anyhow, another sample that I've worked on here for this demo is a timer sample. So Hopper on microcontrollers has the ability to connect a timer to a callback function. So you've got delegates, which are callback functions, delegates like C# in Hopper. So I created a timer that repeats 4 times a second, every 250 milliseconds. And its delegate is fast timer callback. And again, I've lost my connection and I'm going to have to reconnect. Yeah, that's a bit tedious. Anyway, I've got another timer that goes off every 2 seconds. And that one's delegate is timer callback. And then I have 2 alarms. Now, the only difference between an alarm and a timer is an alarm only fires once, whereas a timer keeps repeating. So I've got a first alarm which fires after 10 seconds, and then I've got a second alarm that fires after 15 seconds. But this one's never going to fire, because inside the alarm callback, I cancel the other alarm just to demonstrate that you can cancel. You can stop timers as well. Timers stop. So what we do is after 10 seconds, after we've had 10 loops of the, it's actually 20 seconds. After 10 laps of the 2-second timer, it'll turn that one off and it'll leave the other one going. So it'll stop the timer, and it's giving output to the console as it goes. And then if I hit a key, it's going to cancel everything in exit, and it'll make sure all the pins the LEDs are off. So I've got 2 yellow pins and a blue pin. And I'm using the blue pin for when the alarm fires, and the yellow pins are for the timers. So let's build this. F7 to build. And another thing about this is we've got 2 timers. We've got one every quarter second and one every 2 seconds. And what this will illustrate is that even though you're inside the event handler for, or the interrupt service routine for, even though I might be in this event handler, this interrupt will interrupt this one. So you can have, multiple levels of interrupt in Hopper. Okay, Control F5 to run. Let's run this. Set up all our timers. And you can see there's a fast blinking yellow LED. That's the one that's blinking every half second. And then the one on the right is the slow blinking one. And the half second one, it's the timer is being triggered every half second, but I'm only blinking the LED for 100 milliseconds. Don't want my you'd queue up an infinite number of interrupts if you made the interrupt handler take longer than the period of the interrupt. Anyway, you can see that after 10 iterations of timer one got stopped, so the LED on the right is no longer blinking. So let's separate them a bit. There you can see that only one of the LEDs is blinking, and you might have noticed that the blue one blinked, but let's watch that. So the blue one should blink in loop 5, and it should that's when the alarm triggers in over here, and inside there it looks like the alarm service routine got interrupted by the longer one, the long timer, and then it returned and it cancelled the alarm. And once the alarm was cancelled, anyway, another thing you can see is the IDs, the incrementing integers. So timers and alarm share the same ID pool, and that's why the alarm 3 was cancelled, which is the ID of that second alarm. Okay, I'm going to press escape here. And it's exiting things. It waits 3 seconds to make sure nothing, if one of them's still running, it won't interrupt during the exit. So at the end of the program, I've got a delay of 3 seconds before I clean up and exit. Okay, let's run that again. So we've got our long and our short interrupting. They're both flashing. And then at lap 5, we should see the blue light go on. Well, 10 seconds. There we go. Blue light went on, and it cancelled the alarm. Great. There you go. So I've got functionality working on 32-bit Linux, ARM version of 32-bit Linux runtime of Hopper. The full development toolchain is working, so you could actually recompile Hopper here if you wanted to, because the compiler, preprocessor, linker, assembler, all that stuff's working here. Whole Hopper environment working. And I've gone as far as getting, for the single board computers, I've got digital write and digital read working, and I've got timer interrupts working. I've got some work to do. I need to make pin interrupts work. I need to make analog work. I need to, I could do a lot more. I need to make I2C work, Wi-Fi, SPI. I mean, they probably all work. I just haven't tested them. So I haven't exposed what I haven't tested yet. I should get a NeoPixel library, make a web client so you can do HTTP calls. Yeah. But I'll wait and see if there's interest before I dive into implementing more on the single board computers, or testing more on the single board computers. I'm pretty sure it all works. It just needs to be tested. So I look forward to your feedback. Like and subscribe. And I'll put a link in the description for a Discord server invite in case you want to communicate directly and discuss the subject. Thank you for watching.